guys, today we are going to learn successive differentiation. Before going to the topic, let's discuss all the formulas of differentiation. First, d by dx of x raised to n is equal to nx raised to n minus 1. D by dx of x is equal to 1. D by dx of c is equal to 0, where c is a constant. So the differentiation of a constant is equal to 0. Next, d by dx of root x is equal to 1 by 2 root x. D by dx of 1 by x is equal to minus 1 by x square. D by dx of e raised to x is equal to e raised to x itself. D by dx of log x is equal to 1 by x. D by dx of a raised to x is equal to a raised to x log a. D by dx of sin x is equal to cos x, and d by dx of cos x is equal to minus sin x. Now d by dx of tan x is equal to sec square x, and d by dx of cot x is equal to minus cosec square x. D by dx of sec x is equal to sec x tan x. D by dx of cosec x is equal to minus cosec x cot x. D by dx of sin inverse x is equal to 1 by root of 1 minus x square. D by dx of cos inverse x is equal to minus 1 by root of 1 minus x square. D by dx of tan inverse x is equal to 1 by 1 plus x square. D by dx of cot inverse x is equal to minus 1 by 1 plus x square. D by dx of sec inverse x is equal to 1 by x into root of x square minus 1, and d by dx of cosec inverse x is equal to minus 1 by x into root of x square minus 1. Now we are going to discuss some rules of differentiation. First one, d by dx of ku is equal to k du by dx, where k is a constant. So when we are differentiating ku, here k is a constant, so we are taking it outside. So k into du by dx is the result. So the constant is taken outside and the differentiation of u is taken. Next is d by dx of u plus or minus v is equal to du by dx plus or minus dv by dx. So in the case of addition, we differentiate each term u and v separately. So it comes like this: du by dx plus or minus dv by dx. Next is d by dx of u by v. Here the differentiation of division is done. So in the case of division, we take the denominator first, and that is v into du by dx, and the differentiation of the numerator u is done, and minus u is taken. Then the numerator u is taken, and the differentiation of dv by dx, the denominator is done. So first of all, what is taken? Denominator is taken and the differentiation of u numerator is done, and minus u is taken, that is numerator is taken and the differentiation of the denominator is done, and divided by, at last divided by v square. Next, fourth one, d by dx of u into v. Here the differentiation of multiplication is taken. It's equal to u dv by dx plus v du by dx. So first u is taken outside, and the differentiation of v is done, plus v is taken outside and the differentiation of u is done. So this is called quotient rule, and this is called product rule. We have learned it before in our lower classes. So this is quotient rule and this is product rule. Next is chain rule. Here dy by dx of dx is equal to dy by dt into dt by dx. Here dy by dx is just converted like this by multiplying and dividing by dt. So if you are multiplying and dividing with dt, it surely cancel out. That means it is same as dy by dx. So dy by dx can be written as dy by dt into dt by dx. So it is written in terms of dt. So we are writing the second one. Dy by dx is equal to dy by dt into dt by du into du by dx. Here the dy by dx are written like this. First of all, multiply and divide by dt, then multiply and divided by du, and here dx and dx is also present, and here dy is also present. So it is surely cancel out, du also surely cancel out. So the result will be dy by dx itself. So instead of writing dy by dx, we can write in the form dy by dt into dt by du into du by dx. So this is chain rule. Guys, next let's see how to differentiate the function of x. So let's see an example. D by dx of f of x the whole raised to n. Let's check it out how to differentiate this one. So before differentiating, let's recall the formula. D by dx of x raised to n is equal to nx raised to n minus 1. Compare this. Here instead of x raised to n, here f of x is used to, here a term x is used. Instead of that, in this we are differentiating f of x, so the function of this term is taken here. So when it is taken, next let's see how to differentiate a function of x. So let's take an example. D by dx of f of x the whole raised to n. Before differentiating it, let us check it out. The formula we have learned earlier. So d by dx of x raised to n is equal to nx raised to n minus 1. This is the formula we learned here. Compare this to this one. So here x, instead of x raised to n, here f of x is used. So how to differentiate this one? Here a function of x is used. Here a term x is used. Here instead of that a function of x is used. So let's check it out how to differentiate a function of x. So d by dx of f of x will be equal to n f of x. So n f of x instead of x, here f of x is used, the whole raised to n minus 1. So n f of x the whole raised to n minus 1 into the differentiation of this f of x is also has to be done by dx of x of f of x. So when in the case of differentiation of a function, we have to again differentiate this function. So in the next steps, okay, after differentiating using this formula, we have to differentiate the function inside once more. So this is the case of differentiation of a function. Let's take another example. Let's check out another example. D by dx of sine of f of x will be equal to, before that we know that d by dx of sine x is equal to cos x. So d by dx of sine of f of x will be equal to cos of f of x. Since f of x is a function, we have to differentiate f of x once again. So d by dx of f of x. So next example, d by dx of tan x, tan of f of x will be equal to, we know that tan x is equal to sec square x. So here we will get sec square f of x into d by dx of f of x. I think you got it. We will do one more example. D by dx of So d by dx of log of f of x, it will be equal to, we know that d by dx of log x is equal to 1 by x. So here d by dx of log of f of x will be 1 by f of x into the differentiation of f of x, d by dx of f of x. Next one, d by dx of tan inverse f of x. So it will be equal to, before that we know that d by dx of tan inverse x is equal to 1 by 1 plus x square. Is it right? Yes. So 1 by 1 plus x square. So here it will be 1 by 1 plus f of x square. So here since it is f of x, we have to do the differentiation of f of x too. So into d by dx of f of x. So I hope you got it, how to do the differentiation of a function of x. Now let's go to next some of other formulas. After that we will go straight into successive differentiation. Now guys, let's see these three formulas. D by dx of x square is equal to 2x. D by dx of 2 raised to x is equal to 2 raised to x log 2. And d by dx of x raised to x is equal to x raised to x into 1 plus log x. So don't get confused by these formulas. The first one x square, next 2 raised to x, and third one x raised to x. So when it comes x raised to x, we will write like this, x raised to x into 1 plus log x. So 2, when it comes to 2 raised to x, the answer will be 2 raised to x log 2. This is a formula we have learned earlier. We call it d by dx of a raised to x is equal to a raised to x log a. So it can be 3, 4, 1 or anything. This a can be anything, not only 2. This is an example for that. Okay. So I hope these formulas are clear for you. We will see some more formulas, and after that we will go into problems. Now see this, d by dx of y is equal to dy by dx. Now see d by dx of y square. How we will do this? See this, we already know that d by dx of x square is equal to 2x using this formula. Using the formula, d by dx of x raised to n is equal to n x raised to n minus 1. 2 x raised to 2 minus 1 is 1. So 2x. So we can do this dy by dx into y square in the same way, but look at the denominator. Here the differentiation is in terms of x, but we have to differentiate y square. Since the differentiation is in terms of x, we have to differentiate, first of all differentiate y square by using this formula. Then we have to again differentiate y, because the denominator is in terms of x. So we are differentiating in terms of x. So we have to first differentiate y square, and then once more we have to differentiate y. So let's see. d by dx of y square will be equal to 2y. So we differentiated y square, then we have to again differentiate this y into dy by dx. So this is the answer. Next one, d by dx of y cube is equal to, this is also done in the same way. The differentiation of y cube is 3y square into the differentiation of y square. The differentiation of y. Dy by dx. Okay, so this is its answer. Next, let's go straight into successive differentiation and its problems. So that's all for today. In the next class, we will start successive differentiation and its problems.